Have you ever wondered how food can go from cold to steaming hot in just a few seconds, all with a single press of a button? All we do is place the plate inside, press start, and boom, hot food, no fire, no pans, no sizzling sounds like on a stove. It feels like magic, doesn't it? But because we use it so often, we tend to stop questioning it. How exactly does a microwave heat food? Does it cook from the outside in, like a traditional oven, or the other way around? And why does it sometimes leave the center of your food cold, while the edges burn your mouth? These are questions most people have, but few truly understand. You might have even heard rumors that microwaves are dangerous, that they cause cancer, that they ruin food molecules. But how true is any of that? In this video, we're going to dig deep into this small device that silently revolutionized how humans eat since the mid-20th century. We'll talk about its history, how it works, and fascinating facts that will make you see your microwave in a whole new light. Don't worry, we'll keep it simple and friendly, because everyone deserves to understand the tech they use every day. All right, let's begin the story. Microwaves weren't invented after years of intentional research like computers or electric cars. In fact, their discovery was completely accidental. Let's rewind to World War II, around the early 1940s. A man named Percy Spencer, an engineer at a company called Raytheon, was working on radar technology. It was military tech, crucial for the war effort. Percy was surrounded by high-powered electronic devices, one of which was called a magnetron, a tube that generates microwave radiation. One day, something strange happened. The chocolate bar in his pocket melted. No heat, no fire, no hot air around him. That caught his attention. The next day, he placed popcorn kernels near the magnetron. Result? They popped. Then he tried an egg. It exploded. That's when Percy realized something big. The magnetrons or microwaves were cooking the food. Raytheon saw the potential and moved fast. In 1945, they built the first microwave oven prototype. It was the size of a double-door fridge and weighed over 600 pounds. It took years to make it affordable and compact enough for homes. By about 1955, microwaves started entering American kitchens. The rest is history. Today, it's hard to imagine a kitchen without one. So how does a microwave heat food? Is it like a conventional oven that cooks from the outside? Or is it something completely different? Let's break it down. The term microwave refers to what microwaves, a type of electromagnetic wave. A microwave oven generates these waves at around 2.45 gigahertz of frequency. When these waves hit your food, they don't just bounce off. They would penetrate the food and cause water molecules inside to start vibrating rapidly. This vibration creates friction. Friction creates heat. Think of it like rubbing your hands together really fast. They get warm, right? Now imagine that on a molecular level. Since almost all food contains water, this process works pretty efficiently, but it's not perfect. If your food has uneven moisture, you'll get uneven heating. That's why sometimes the center is cold, but the edges are scalding hot. Also, materials like metal reflect to microwaves and can cause sparks or fire. So putting metal bowls or foil inside, bad idea. But when used properly, a microwave is safe, fast, and reliable. So why did microwaves become such a household favorite? First, to speed. Food that might take 15 minutes to heat on a stove can be ready in 2 minutes in a microwave. This is a lifesaver for college students, busy workers, or late-night snackers. Second, microwaves are energy efficient. Because the heat is directed right into the food, not the surrounding air, very little energy is wasted. Third, they're generally safer than open flames or gas burners. No risk of leaving the stove on, no chance of burning your sleeve over a flame. And let's talk of versatility. You can defrost frozen meat. You can steam vegetables. You can make popcorn, melt butter, heat baby formula, even bake mug cakes. All with a compact appliance that fits in the corner of your kitchen. Over time, designs have become smarter and more multifunctional. And as our lives get faster, microwave ovens adapt to help us keep up. Despite all that, microwaves still have a spooky reputation in some circles. You've probably heard things like, microwaves destroy nutrients, microwaves cause cancer, microwave food becomes radioactive. Let's clear that up. Research has shown that microwaving actually preserves nutrients better than boiling, because the cooking time is shorter and no nutrients are lost in the water. And as for cancer, major health organizations like the World Health Organization and the FDA confirm properly functioning microwave ovens are safe. The microwaves stay inside the oven. They don't linger in your food. They don't make your food radioactive. As long as you don't use damaged microwaves or open the door while it's running, you're fine. So most fears come from misunderstandings or outdated rumors passed down over the years. That's why it's important to not just use technology, but understand it. Because when you understand, you stop fearing the wrong things. We live in a time where incredible technologies are part of our daily routines. And because we see them every day, we stop noticing them. Microwaves are one of those things. We use them constantly, but rarely ask how they work, who invented them, or what makes them tick. Now that you know the full story, from Percy Spencer's melting chocolate bar to the physics of vibrating water molecules, maybe you'll see your microwave with a little more respect. Maybe the next time you press start, you'll remember, behind that familiar ding sound, there's science, there's history, there's a little bit of magic, and a small accident during a war that changed how the world eats forever. If you enjoyed content like this, click subscribe and like to support this channel, and share it with a friend who needs insights like— Ever wondered why almost all microwaves look kinda the same? A rectangular box, a turntable inside, a door with a mesh window. That's not just a coincidence. Every part has a very specific function. Let's start with the wide turntable, that spinning plate inside. Microwaves don't heat food evenly in every part of the oven. So the turntable rotates your food to distribute the microwave energy more uniformly. Without it, you'd likely end up with hot and cold spots, or even a frozen center. Then there's the door with the metal mesh. You've probably noticed that strange dotted pattern on the microwave door window. That's a Faraday shield, a metal mesh that blocks the microwaves from escaping. Microwaves are much larger in wavelength than visible light, so light can pass through, but the waves, can't. That means you can safely watch your popcorn popping without worrying about radiation leaking out. There's also the magnetron, the part that actually generates the microwaves. It's usually located on one side of the oven and connected to a waveguide, a tunnel that directs the microwaves toward the cooking chamber. Some advanced models even use inverter technology, instead of pulsing on-off power, which allows more precise temperature control and better texture for delicate foods. All these elements, from the shape to the mesh to the spinning plate, work together to make the microwave safe, effective, and compact. Oh, it's not just a box. It's a carefully engineered mini laboratory sitting quietly on your counter. Now that we understand how microwaves work, why not try some safe, simple experiments at home to see the science in action? Let's start with one of the most popular, testing microwave interference patterns. Here's how. Take a plate and line it with slices of cheese or mini marshmallows. Remove the turntable so it doesn't rotate. Microwave on low for a few seconds and watch. You'll notice some parts of the cheese or marshmallows melt faster than others. Why? Because microwaves create standing waves inside the oven, spots where energy is stronger or weaker. By measuring the distance between the melted spots, you can even calculate the wavelength of the microwave radiation. Another cool trick? Put a damp paper towel over a piece of stale bread and microwave it for 10 seconds. The moisture rehydrates the bread, proving how the water molecules carry and transfer heat rapidly in this environment. And for the curious, microwave a grape, cut almost in half, to witness a tiny plasma effect. Just be careful. This one's more of a visual demonstration and shouldn't be overdone. These experiments are more than just party tricks. They show how science isn't locked away in labs. It's in our kitchens, in our snacks, in our everyday routines. They help us move from just using technology to understanding and respect. The microwave oven hasn't stayed frozen in time since it entered our kitchens decades ago. Like everything else in tech, it's evolving. Today, we're starting to see a new generation of microwaves, smarter, more efficient, and deeply connected to our digital lives. Let's talk about smart microwaves. These aren't just microwaves with digital buttons. Some models are now voice-activated, working with smart assistants like Alexa or Google Assistant. You can literally say, "Reheat pizza," and the microwave figures out the time and power level automatically. Others come with high barcode scanners or smartphone apps. You scan the package of a frozen meal and the microwave pulls instructions from the cloud. No guessing. No overcooked centers or underdone edges. It's all automated. There's also a shift in how microwaves deliver heat. Traditional microwaves pulse on and off, but newer inverter technology models allow continuous and variable power, giving more precise control, perfect for things like melting chocolate or softening butter. And let's not forget sensor cooking. These models measure steam and humidity levels to detect when your food is ready. That means no more overcooking your leftovers or exploding soup bowls. Even the form factor is changing. Some companies are experimenting with when microwave drawer designs, built into kitchen islands, saving counter space. Others combine microwaves with when convection, or an air fryer, features, turning the humble microwave into an all-in-one cooking station. As we move toward a future where convenience, health, and sustainability matter more, the microwave is adapting right along with us. It's not just a reheating box anymore. It's becoming a partner in your kitchen workflow, learning, adapting, and even predicting your habits. Let's take a moment to reflect. We often reserve our admiration for futuristic gadgets, smartphones, drones, self-driving cars. But some of the most powerful innovations are the ones that slip into our daily lives so seamlessly, we forget they're even technology. The microwave is a perfect example. It wasn't flashy. It didn't scream innovation. But it quietly reshaped how we eat, how we save time, and how we think about cooking. It brought science fiction into everyday kitchens. And it all started with a man, a radar system, and a melted chocolate bar in his pocket. Next time you use your microwave, take a second. Appreciate that inside that humming metal box, molecules are dancing. Electrons are racing. Physics is unfolding. And it's all happening silently, in just a few seconds, to bring warmth to your food and convenience to your life. In the end, technology doesn't have to be loud to be revolutionary. Sometimes, the most profound innovations are the ones that just go ding. If you enjoyed content like this, click subscribe and like to support this channel, and share it with a friend who needs insights